Welcome to this explainer. We all use AI every single day, right? But have you ever stopped to think about what's actually powering it all? Behind that smooth digital screen is a massive physical world of energy consumption, and it's growing like crazy. Today, we're going to pull back the curtain on the hidden cost of our intelligent future.
Okay, so to really wrap your head around this, let's start with a simple comparison. A quick Google search uses a teeny tiny amount of electricity, but asking a generative AI, something like ChatGPT, a single question, that can use a whopping 10 times more energy. Now think about that and multiply it by the millions, maybe billions of queries happening every single minute. You start to get a picture of just how big this challenge really is. And get this, that's just the power for a single query. The energy it takes to train one of these huge AI models in the first place. It's absolutely staggering. We're talking about enough electricity to power a small city, not for a day, but for weeks, maybe even months. It's a number that's almost hard to comprehend.
So this colossal, frankly, unprecedented demand for energy has created something totally new in the tech world. And to understand it, you kind of need a metaphor. Let's call it a hungry beast. A beast that's always growing and whose appetite for electricity is, well, it's insatiable.
And this beast? Well, it's the modern data center. You can think of it as the physical brain of this whole AI revolution. And as AI gets smarter and becomes a bigger part of our lives, these data centers are just popping up everywhere. And their collective hunger for power is growing at an exponential rate. And here's where the real problem kicks in. There's this fundamental mismatch in speed. See, we're incredibly good, incredibly fast at building these huge digital factories, these data centers. But building the power plants needed to actually run them, that's a much, much slower and more complicated process. And this creates what we're calling the power gap. And this chart just lays it all out, plain and simple. Just look at the difference between data center growth and how fast we can build new power plants. We are building the demand for electricity far, far faster than we are building the supply. It's not just a gap, it's a chasm. And honestly, it's getting wider every single day.
So this leads us to the central challenge facing not just the tech industry, but really the whole world. I mean, if the engine of all our future progress, AI, needs more power than our grids can even give it, what happens then? How on earth do you solve a problem of this magnitude?
Well, faced with what is basically an existential crisis, the biggest names in tech are turning to one of the most powerful and, let's face it, most controversial energy sources on the planet. They are making a massive, high-stakes bet on nuclear power.
And this is not some fringe idea we're talking about. No way. This is the big leagues. We're talking about the giants of the industry, Microsoft, Amazon, Google. The very companies building these power-hungry AI models are the ones now leading the charge into the world of nuclear energy.
So their game plan is basically twofold. For the short term, they're buying up existing nuclear plants, or locking down all of their power output. That gives them a steady, carbon-free supply of juice for their data centers right now. But for the long term, they're playing a different game. They're investing a ton of money into the future of nuclear power itself.
And that future, well, it looks nothing like the giant, sprawling nuclear plants you might be picturing. The technology that's at the very heart of their big, long-term bet is a whole new breed of reactor, one that's designed for the completely new demands of our century.
They're called Small Modular Reactors, or SMRs for short. The two words you really need to remember here are small and modular. See, unlike those massive custom-built plants that take a decade or more to build, SMRs are designed to be built in a factory, almost like parts on an assembly line. This means they can be built and put together on-site way more quickly and flexibly. Now, what's so fascinating about this, when you look at the comparison, is how SMRs seem perfectly designed to solve the exact problems that make old-school nuclear a tough sell for big tech. They're compact, so you can literally put one right next to a data center. They're built in a fraction of the time, and because they cost less and are modular, the massive financial risk just shrinks. It's basically nuclear power custom-built for the age of AI. So this brings us full circle right back to the central high-stakes debate at the heart of this whole tech revolution. We've got this tool with unbelievable promise, but its hunger for power is forcing us to make these enormous, world-altering choices about how we generate energy.
On one side of this, you have the incredible promise of AI. The optimists believe it could be the key to solving humanity's biggest challenges. Things like designing brand new medicines, creating super efficient energy grids, or even modeling climate change with an accuracy we've never seen before.
But then, there's the other side of the coin. There's this deep, profound irony. What if the tool we need to solve these massive problems ends up creating an equally massive problem of its own? The physical demands of AI are real,
They are here now, and that hungry beast has to be fed.
And so we're left with this powerful, really urgent question. We are in a race to build this intelligent future, and we're betting on huge technologies like nuclear power to fuel it. But it forces us to ask, are we creating a virtuous cycle where AI helps us manage our resources better? Or are we creating a vicious one where our quest for intelligence just ends up consuming them? That, right there, is the dilemma at the very heart of AI's hunger for power.